So let's do the integral of tangent cubed of x. We should first keep in mind that tangent of x and secant squared of x go well together since the derivative of tangent of x is secant squared of x, which means we could do a u substitution if we had an expression in terms of tangent of x multiplied by a single factor of secant squared of x. The first thing we should do is rewrite the integrand as tangent of x times tangent squared of x, and we can rewrite the tangent squared of x term as secant squared of x minus 1, using the identity tangent squared of x equals secant squared of x minus 1, which comes from the identity tangent squared of x plus 1 equals secant squared of x. If we expand the expression, we end up with the integrand being tangent of x times secant squared of x minus tangent of x. We have a sum of terms, which means we can integrate tangent of x secant squared of x and negative tangent of x separately. So let's first do the integral of tangent x times secant squared of x. Tangent x secant squared of x is nice to work with since we have a single tangent of x term multiplied by a single factor of secant squared of x, and the two terms go well together. If we let u equal tangent of x, then du equals secant squared of x dx, and the secant squared of x dx in the integral becomes du, and tangent x becomes u, so this is just the integral of u du. The integral of u is just u squared over 2 plus the constant of integration c, and since u equals tangent of x, this just becomes tangent squared of x over 2 plus c. So the integral of tangent x secant squared of x is tangent squared of x over 2 plus c. The integral of tangent of x is a standard integral, so I won't go over the full solution, but I'll show the work. Basically, we rewrite tangent of x as sine of x over cosine of x, then take a constant of negative 1 out of the integral to make the integrand negative sine of x over cosine of x. We then substitute u equals cosine of x to get negative integral of 1 over u du, and that turns out to be negative ln of the absolute value of u plus c. Since u equals cosine of x, the expression becomes negative ln of the absolute value of cosine of x plus c. We can use the properties of the absolute value and logarithm rules to rewrite the expression as ln of the absolute value of secant of x, so we don't have the negative sign at the front. So the integral of tangent of x is ln of the absolute value of secant of x plus c, which means the integral of negative tangent of x is negative ln of the absolute value of secant of x plus the constant c1. Technically, we already used c, so to not have the negative sign before the constant of integration, I had to use another arbitrary constant. But it doesn't actually matter because when we add up the two integrals we have in our original problem, the result is just some arbitrary constant at the end anyways. So since the integral of tangent x times secant squared of x is tangent squared of x over 2, and the integral of negative tangent of x is negative ln of the absolute value of secant of x, the integral we have here is equal to tangent squared of x over 2 minus ln of the absolute value of secant of x plus the constant of integration c.